Hello, sir. Hello.
Hello, hello.
Sir, yeah, sir, you are audible and we can see your screen. So it is properly visible. You may continue the presentation, sir.
Okay, so
Yes, sir.
I start from all over again. Okay, so now I'm starting. Is that okay?
Yes, yes, you can start from the very beginning, sir.
Okay,
And from our side, we are also recording the session. And if possible, from
perfect.
your side also, you can keep it in the recorded mode. So anyhow, if we lost the connection, then we will have the recorded part.
Okay, I hope the connection will be good this time. And I
Yes.
will just cut my video maybe in order to be sure there is no issue regarding this. You know, I'm not
Yes,
a
yes.
robot. I'm not just cutting the video. Okay.
Okay.
So my talk and within the last 30 minutes, and I hope they will have questions, I will talk about application of AI in digital agriculture, and more precisely about agentic AI. That means AI based upon agents, which is represent a lot of interest today in the development of AI application. And I will give a concrete example concerning a project which is running in Madagascar concerning rice fields. So it's a very interesting era today in computer science and agriculture because we are facing three major paradigm shifts. The first one concerns data. And I will take here the words of Jim Gray. Jim Gray was got the Nobel Prize in computing in 20 years ago. And he said very practically, we are entering the fourth paradigm of science, which is a data science. Data is a major raw resource of this millennium. So we enter that. That means consequence for data management, data communication, and data analysis with mathematical tools or artificial intelligence. Second, paradigm shift is the fact that data are entering the fields. A field is, I would say, an alive being. Any plant is a live being because it's producing data and it communicates. And that's the definition of life in biology. So here we are putting data, we are putting IoT in the field in order to get data, integrate data, and based on based on AI tools, we're going to analyze them in order to monitor crops, to detect disease, to optimize water, and eventually to prevent any form of anomaly and to detect any degradation of ripening or etc., and to identify eventually good harvest time. And in computer science and AI application development, we are entering a fascinating era, which is called the agentic AI. We see that agents are autonomous AI applications interfacing with large language model, LLM. So application development enter a new era. Sorry, sorry, is there a problem? Because I heard somebody talking, or maybe this person has to cut off the microphone.
Yes, so we have mute her. We have mute her, so you can carry on.
Okay. So I put that date of November last year because that was the time Anthropic released an open source MCP model protocol for agents. And this protocol has been proposed by Anthropic, which is a Claude LLM, in November. 2 months ago, Microsoft and Google signed for it, and last month it was Amazon. So this is going to be the open source standard protocol in order to build and orchestrate and make a communication between multiple agents inside a company. Anytime there is a data flow in a company, there will be tomorrow an agent to assist any worker. So 2 parts: strategic vision of AI in agriculture and agentic AI, concrete agentic infrastructure we build. I will skip some slides and I will send to Dr. Dibia, to my colleague, the PDF of the slide, but I will just pick up some in order to be within this time. I would not say too much words on this kind of slide, putting the dimensions of the interest of digital agriculture for the future. The fact that starvation is an issue. Africa is going to double its population by 2050. Water scarcity, climate change. The 3 major dimensions of interest in terms of new services which have to be based upon data and be developed. I will go through that, saying among the sustainable goals for 2030 by United Nations, digital agriculture represents a very important stuff. I will not comment the 6P of data-driven agriculture in terms of production, prevention, prediction, personalization, precision, and phone ubiquity. The fact that every farmer of the future will have a smartphone in his pocket, a computer in his pocket. So talking about AI is talking about data. It's a couple. We cannot have AI without data, without a huge amount of data. And I put tsunami of data just to emphasize the fact that Google gave a good number. They say from the beginning of humanity 4,000 years ago, when the man started painting on caverns, up to 2020, man produced 6 exabytes of data. An exabyte is 10 to 18. 6 exabytes of data. And today, that's the only figure I give, the humanity produce 1 exabyte every day. So data tsunami, we are living there. Artificial intelligence, I said Luc Julia doesn't exist. Luc Julia is the founder of Siri, the human, the voice interface for Apple, etc. And he said it doesn't exist. What exists today is a set of tools. And we have mathematical tools, computer science tools, machine learning and deep learning tools. And what is important is that I put that here in gray, is the fact that generative AI, after the huge success of ChatGPT in 2022, became as a strong tool to be integrated in any data flowing company. And since any company produces data about customers, about products, you can have many applications. Anytime you have data, you have a generic AI application. So the AI tools, I will just emphasize the heart, which is the disruption of deep learning engineering. You see around deep learning, deep neural networks, you have deep learning neural networks and different variants of it. And you have a ChatGPT and you have transformer-based language model. So deep learning is completely disrupting the development of AI application today. First of all, concerning data management, we have many sources of data, many types. Structured data, from a computer science point of view, we talk about structured data, semi-structured data, and unstructured data. Structured data means you have a schema to design the real-world environment you are interested in. Semi-structured data means you have labels to to prefix and suffix the data. And unstructured data, you have no labeling and no schema. So we have the three major types of data, and we can have decision support data. So we have these four major types of data from a computer science point of view, with major tools, SQL, OQL for structured data, SparkQL for semi-structured data, unstructured data with no SQL, with k-value system. So you have a graphical representation of it, and you see something which will be very important for AI, which is vector database. Vector database, they are part of RAG system, as you will see later. So vector database is fascinating because that's part of the history of computer science, which, globally speaking, doesn't like any variable length record. Whatever we have variable length data, and when we want to store them, human intelligence put some effort to transform it to fixed size data. Computer science like fixed size data. And here, vectors, binary vectors, represent a uniform way to model any type of data. Could be text, could be PDF, could be sound, could be music, could be videos. You can transform them into vectors. And that is very important because large language models are based, and transformers are based on vectors. So we have here a tool in order to create a homogeneous form of representation of any type of data which exists within a company. So a vectorization and a coupled word, which is embedding. Embedding means vector representation of any object, but maybe with higher dimensionality than one level. So vector database exists to store data of any form. I will not talk about ubiquitous agriculture, just meaning the fact that every farmer has a smartphone PC on his pocket. I will take the example of rice in Madagascar, which is part of a European project called DFARM. We are managing 2 European projects on digital agriculture. And one of them has 3 digital farms in Africa, in Benin, Ivory Coast, and Madagascar. In Madagascar, it concerns rice. Situation of the rice is terrible in Madagascar. There were climate change, but Madagascar was exporting rice 15 years ago, and now it's importing rice to feed the population. The production of the yield of an hectare in Madagascar for rice is 2.5 tons. World average is around the double, 5. And China is about 3 times, 7 tons per hectare. That means China is using data, is using drones, is using sensors in order to monitor crops for rice. So that is one important dimension in order to be sure that production will be at its best and monitor correctly. So predictive AI, what I called AIoT, is based upon IoT, Internet of Things. Things we put in the field or around the field in order to produce data. So IoT consists of sensors. We have today in agriculture maybe more than 20 types of sensors which can be put in the field, mainly for humidity, but eventually for soil nutrients and pesticide or chemicals or whatever, and weather sensor too. And then we have cameras. We have cameras which can be on drones, which can be on robots, and which can be on satellites. And of course, a robot is also an IoT which can provide services in the field. But if we talk about family farming, which is our ambition in the two European projects, which concern 80% of the farmer in the planet, then we have to look at cheap devices. And sensors and drones belong to that category, not robot, and not eventually satellite image. But putting a multispectral camera on a drone is not that expensive, and we could monitor a crop, detecting diseases, detecting anomalies, or ripening. We use AI, machine learning, and deep learning technique to detect disease and eventually dropped anomaly. So that was an example of the first architecture we developed 3 years ago for the European Deep Farm project. So you see web data above, providing weather data, information on weather, or providing PDF version, PDF solutions, PDF reports, or whatever you could find on internet. Eventually courses. Then we have sensors, providing time series data concerning soil moisture, soil temperature, air temperature. So we have sensors. Then we have drones. We can have a real-time sending of image or through a disk and then do that offline. That depends on the communication which exists on the field or not. And then we can use also satellite images, etc. All this data, time series data, web data, semi-structured data from data coming from real-time drones, images, structured, unstructured data feed up the data lake. So we have a data lake here, which can take all the real-time data. And we can also have historical data in order to compare situations. So in the data lake, we have two types of data, historical data and real-time data. And then on real-time data, we can apply machine learning algorithm and do prediction. That's the typical IoT machine learning, deep learning pipeline architecture we built for initially on Deep Farm. So the big wave of generative AI started with ChatGPT in 2022. I put DeepSeek to say the open source Chinese alternative to the American ChatGPT. But what is important from that is that everybody on this planet, everybody, will have tomorrow a digital assistant in its private life, for its finance, whatever, in a public life. He has to take the car and to traffic, etc. He will have a digital assistant. And finally, in the professional life, anytime you have data coming out the picture, you will have a digital assistant called today. After my conference, you call that an agent, an AI agent. From the 3 dimensions of digital agriculture of the future, that's part of a seminar I did for Europe in Uruguay last October. I put 3 important points. And I will just comment the second one, the data commons. It's important, since data are important, that every culture open the door to the creation of something commons for everybody. Jim Gray himself, when he talked about the fourth paradigm of science, which is data-centrics, he said any tool concerning data, management, communication, analysis should be free on this planet, because that's part of the community, the human community, to share that information and share it in order to have a better crops, better health. So in the area of health and agriculture, it's fundamental that these data commons exist and be shared for the well-being of humanity, with open source products to analyze them too. And the third dimension was every farmer of the future will have a digital assistant in his pocket, a digital tutor. That means an AI agent for every farmer for every field he may manage. And important here, that was the case in Africa, I'm quite sure in India, is to be able to integrate local and sometimes very specific local customized knowledge concerning agriculture and health. That's something which is common in both cases, that there are historical know-how in terms of agriculture which should be kept and used instead of maybe some global solutions which could be expensive and exist at the world level. So the virtual farming tutor is an AI application interfacing with LLM, which represents generative access to existing data. We have today with LLM millions of websites which are indexed. And within this website, that's information which has been stored, which existed before, not so data of the present, which is going to be built. But concerning the past, that's knowledge which could be generated from this existing data. And that's this access, this every LLM of the market provide an API for application developer in Python or whatever library in order to write down application integrating this public knowledge of the past. And tomorrow, this virtual farming tutor you will see will be an AI agent. And I will say an AI orchestration agent. And I will show you concretely what it means. We'll not comment too much on LLM and transformers. The key paper for transformer is a paper from Google just less than 10 years ago, with which is attention is all you need, and a transformer is described. A transformer is an NLP, natural language processing tool, using self-attention mechanism and parallel processing. I will give you a small example behind, just to be sure everybody can follow. A large language model is built upon transformer. The best thing is to go into this small example. So we have an input here, a prompt, a query, and this prompt is going to be transformed into tokens. Tokens is, since the prompt is textual, is a piece of text. It could be a word, but it could be less than a word. To make it simple, let's use it as a word. So the input is transformed into tokens, into words. Then you see the word embedding. Embedding means vectorization. Every word will be transformed into a vector. And then you see positional encoding. It's another vector which indicates the position of token in a sentence. And then you see attention feed forward. Here, 3 layers of deep learning are represented. Attention gives semantic weight to every token. And feed forward is a neural net. It's a deep learning net without feedback. So neural net here. And you see you can have in parallel deep learning layer transform into statistics and probabilities. That means what is the basic of transformer is probability. What is the next word to be put in a generated text? This is calculation. This is calculated. That means LLM and transformers do not create text. They do not create new text, they generate text not coming from ideas, not coming from imagination, but from calculations. And then
Hello. Sir, I think so. There's a problem with your connectivity. We can't hear anything. Hello, sir. Divya, sir.
Hello.
I think so, sir, has a problem with his connectivity.
Oh, he has lost the connection. I mean, she's not there. Wait, just I will again ask him to join the session. Thank you, sir. Just wait for a minute. Yeah?
Yeah, yeah.
wow. I need to share my screen, and you should send me the authorization.
Yes, sir. You can share the screen.
You need to give me the authorization to share my presentation.
You are
Right.
already a host. You can share it.
Okay, let's see. No, he said sharing is not activated. You are the host. You should give me the authorization for this session.
So just 1 minute. I'll confirm that whether you are in the host mode or not. Just give me 1 minute.
I cannot.
Yes, just 1 minute.
I still cannot. Huh? I still let me know when I can share. I'm trying randomly.
To host again, then you can share the screen.
Let's see.
Yes, just 1 minute.
No, no, it doesn't. It's not possible yet.
One hour.
Yeah, now I can.
Yes, sir. Yeah, now you can share the screen.
Yeah.
Yeah, the session is going on very fine, sir. You can just resume from the same slide, sir. Yes. Yes, sir. We can see the screen.
So you should see it. Now it's okay?
Yes, yes. Yes, it's okay, sir.
Okay, let me just take this off. Okay, so I was saying that an interesting application of LLM is to provide the clean data for labeling. That means the LLM which will apply transformer on this data will give better response, better answer with no hallucination, for instance. And that's a very important stuff. Nobody talk about that, but it's very important. Nobody except at least I just put 2 words, 2 people. So here you see in the US, data annotation, I said the shovel and pickaxe of the AI rush. Alexander Wang is the youngest billionaire in the US. You can see his story about data annotation. He's a friend of mine in Africa, Kate Callott. Is going to do the same in Africa in order to provide clean data, annotated data. And that's very important. So very important word in order to understand the future of agentic AI is what is called a RAG system. RAG system started 4 years ago, 5 years ago. There is an important paper indicated below. But this retrieval augmented generation has a very simple idea. The very simple idea is to connect internal private data from a company, from your life, whatever you want. Internal data. You don't want this internal data be public, be accessible by an LLM. But you would like to merge this information you may infer from internal data with, of course, the public data managed by an LLM. And that's called a RAG system. And that consists in enriching the user prompt by data coming from internal data sets. And that could be done, again, through vectorization, through embedding. And that's very interesting. So retrieval augmented generation, you have retrieval, internal database data sets, being transformed into vectors, what is called embedding. And then generation, enrichment of the prompt in order to generate a response which integrates local information. That's an example of a typical transformer in a RAG system with vector database. You have the question, the query, and you see the query transform into an OpenAI text embedding. I will talk about embedding later. But the query itself is transformed into a vector. Then this vector, which is green, is used in a vector database. What is feeding the vector database is all the internal data. You see in the bottom PDF parser. You see the PDF. And the PDF could be large. And again, systems work in smaller parts. We don't want to work on very long information, so this has to be split into chunks. Globally speaking, it's semantic chunks. And every chunk will be transformed into a vector stored in the vector database. Here I indicate ChromaDB, Pinecone. There is another one more popular, which is called Milvus. And you have here for vector database, any big database vendor of the market, Oracle, Microsoft, Google, they are providing, since last year, vector database. So traditional DBMS vendor or new open source vendors provide vector database. So everything, the query and the internal data are managed into the vector database. And therefore, due to the query is going to work on a vector database. We do not have any SQL interface here. We have what we call the similarity interface. So that means you can look at all the similar chunks corresponding to the query, which have more or less with some bits a bit different, but you have using vectors, you identify similar vectors. And the similar the chunks corresponding to the similar vectors is aggregated with the query. So the initial prompt, the initial query is aggregated with the selected chunks in the vector database to get the final prompt proposed to the LLM. So that is the philosophy of a RAG system. So we have it in a different way with using Milvus here, using Yama index or LangChain, that's the same. So we have enterprise knowledge base, documents are pre-prosed, the documents then go to the embedding model. Same with the query, the user query go to the embedding model. Both the query and the vectorized data are stored in a vector database, and then the prompt and the query, the aggregated prompt is provided to the LLM to get the global response. Embedding, I use that word, vectorization from vector database of prime importance. And we have many open source tools like LangChain and Yama index, etc., which are providing vectorization embedding of different approach. So I quote here different sources: PDF, audio, text, image, video. I put vector representation with binary data and vectors. Then you see in the vector database we can apply a similarity research for approximate and error neighbors similarity. There are many tools here. And then we go and aggregate the prompt, post to the LLM to get the answer. Important to use the words also of load, transform, embed for RAG system, which is similar to the extract, transform, load, which existed on data warehouse for structured data analysis. So here we have sources, we load these sources, we transform them, and we put vectors, we store them in a vector database, and then we can retrieve. So chunks are very important, and there are a global strategy of chunks. So here you have the same kind of project, which is presented here with documents split into chunks, then embedding, transformation into vectors, and then etc. You go, and with LLM, you generate the response. The most popular embedding tool, which is also not only an embedding tool, is LangChain. LangChain is the most important tool. We have, I indicate here a book concerning it. It's open source. It enabled to load, transform, embed, LTE, any type of document. And then, more important than that, to build agents. An agent in LangChain is a chain, therefore the name LangChain, of actions. An agent is an autonomous AI application which can take actions. Embedding with the LangChain, exactly the same. You see the PDF, you see the chunks, then you see the embedding, the vector database, which is included also in LangChain, and then that go through the query of the user and the LLM interface. We talk also about multimodal RAG, just saying we can have any type of input, which could be text, image, audio, video. Now let's move to AI agent, an autonomous AI application generating actions. So here, there is not yet, I could put, but not here, the RAG system, but here, and the internal data, but we have a vector database, we have retrieved documents, we have the user query, accessing at the vectorized document, and the agent, which is building an answer to the client. What is important is that an agent has autonomy, and he makes decisions and actions. Actions could be virtual, like sending an email, sending a WhatsApp, sending a LinkedIn message, or an agent could be actual in the real world, like watering the water, sending robots, a robot for control, a robot for watering, sending the drone for image, taking at that level, etc. So they could have actions, virtual and real life actions. And of course, this needs control by human in the middle. So I said, anytime you have a very interesting guide offered by OpenAI some weeks ago, a practical guide to building agents by OpenAI. And OpenAI select also the MCP protocol I talked about in March with Microsoft. So AI agent is as an API to an LLM, but more than that, not only one, we could have an aggregation of agents, having multi-agent systems, accessing each a different LLM. There could be LLM for image and LLM for text, which could be different. We have different types of AI agent, reactive, proactive, conversational, and multi-agent systems. I go through that. And in the multi-agent workflow, which are of interest, React agent is the simplest one, with you see the query, the LLM, the tools, Google, Microsoft, whatever you want as a web interface. And we have a multi-agent from a workflow, multi-agent system, because we have different data workflow. For instance, let's imagine we have an agent to define my next trip to India. Let's imagine I'm going to India to visit your country during 1 week, and I have my preference in terms of hotel, in terms of bed and breakfast, in terms of restaurant, in terms of visit, cultural visit, etc. And I built an agent for that. And then I keep on my life. And during my night, during my agent is working, find me the best airline ticket, the best restaurant, the best. And I propose and I finalize. I say yes, no, I validate or not the action. So before paying, of course, I will give I should give the validation. That's an agent. We can do this complex task, accessing different websites, preparing a different reservation, etc. So when we talk about multi-AI agent systems or agentic AI, we can have a single agent managing different actions. We can have a network of agents. We can have a supervisor. It's what we implement in the Deep RISE project, in the RISE project in Madagascar, an orchestration agent managing different agents and aggregating. What is fundamental for me in terms of standardization, it's what happened in November last year. End of November, Anthropic, which provides an LLM, Claude, Anthropic released an open source protocol, a model context protocol, an MCP, for AI agents to communicate among them and to communicate with servers. And this led to standardization. And that's fundamental. For time to market application, whatever, you need standards. And therefore, you see, Anthropic started in November. In March, Microsoft and OpenAI ChatGPT, in March, they integrate MCP. Same with Google and Amazon in April. So we are in May. So there will be others, big company coming into the market. Next one will be IBM. And the Chinese, of course, will be there too. The MCP is a client-server architecture, which is very important to in this boosting, in this dynamic area, which is agentic AI, to control and to define the protocol between what exists on the client side and what exists on the server side. So I will not comment more on MCP vulnerability. I will go into the example of the agentic AI architecture we are building in Madagascar for the Deep RISE project. I have a top eBIHAR student there. BIHAR is the name of, it's not the name of a country in India, I know that too, but it means Big Data Intelligence for Human Augmented Reality. It's the name of our master program in France, having an online version in English and French called eBIHAR, master student. It could be student from India at a certain time, working with Oracle. We have agreements with Oracle, Microsoft, and Google for this online program in order to have professional courses on it. We are working on that. So we have, to give you an idea, 110 students, master students in Africa today. So one of them is Hasina, and Hasina is with another group of students implementing the agentic AI architecture for Deep RISE. So Deep RISE is part of a European project undergoing an ongoing project called DeepFarm. And there is a new one starting on fruits farms called Fructor. It's another European project which is starting now for the next 3 years. So it's a very important area for us to use data. We have different source of data, time series data coming from sensors, image data coming from drones, coming from robots, coming from satellites. So this data should be analyzed, and then we should take decisions whether there is a problem of watering, a problem of disease, etc. And we should take actions depending on that. And the action could be, I send a robot, I send a drone to put pesticide, to put whatever. So what is the AI pipeline we built for the digital rice farm? So you see all the input data didn't change, drones, sensors, and web, and we embed, we vectorize all this type of data in LangChain. And then the vectorized database we're using, we could have used LangChain, use Postgres SQL, which has a vectorized dimension. So that's the data lake management of the vector database. And we use different source embedding model stored in SQL, sorry. And then that's interesting. That's we have the orchestration agent, the supervisor, the coordinator, and three types of agents. One type of agent is for image, real-time image coming from drones. Another agent is for time series data coming from sensors. And then internal knowledge, internal data, which could be sound, interview, which could be video, which could be text, PDF, whatever. We have also for this internal data, documented data, which exists, another agent. And we're using open source LLM like a Mistral and DeepSeek on this project. So that's another dimension. And I would like to conclude and give first a global vision of what is agentic AI is part of the history of computer science. Initially, computers manage bits, even though a vector, as we talk today, does consist of bits also. But the computer system, traditional computer systems manage bits. And typical programming language are what we call imperative. We ask the computer to do exactly step-by-step different programs. And the symbol is a Turing machine with a sequential tape. But that's traditional computing based upon bits. Then with AI dimensions, we go, the fundamental element is a neuron, the digital neuron, like in the brain, digital neurons. And here we're not talking about imperative computing, we're talking about inductive computing. That means we do not describe the task in order to get the result. We have to spend time in the prompt. We have to focus on the prompt. We have to focus on the question. And therefore, we see how agentic AI interfacing with LLM consists in enriching prompts, the user prompt, with data coming from different sources, which are going to be aggregating towards the LLM. And here the symbol is a transformer, the calculation of the next word by statistics in the text. And in the future, we'll have bits, we'll have neurons, and we'll have qubits, which is here graph computing and parallel computing. Let's see at this agentic AI in the conclusion. And I would say I had to put one word again ahead is small. Small is beautiful. The present LLM, some key specialists like Luc Julia, Luc said recently, LLM will be dead pretty soon. The future belongs to SLM with good annotated data, coming from big data to good data. So annotation is of prime importance. And small is again on chunks. Sometimes PDF are too large and beyond the size of a potential token, and therefore we have to use chunks. Split the input into smaller size for semantic embedding. And globally speaking, I read Harvard the paper recently saying anything which is big will fail. There are many applications today which are wrapped around ChatGPT. and providing global solutions. They will disappear. They will be fair. What is the future is not this huge Titanic. It will be the set of barks, the set of boats, set of small boats. And what is the future is that the market is eager to look at very specialized, small solutions, AI applications on very specific project. So the future will be a set of small box instead of big agent. There will not be a big agent. And in terms of future, the future of transformer is semantic token. Token with semantics. I mean, chunks, say the words, it will be chunks. And something interesting, not the business model of GPT-5. Je finis. Not the GPT-5 model, not the business part of the GPT-5 model, which is going to, OpenAI is going to sell monthly many big amount of money to get agents, specialized agent, to get a human a human-like assistant. That's a strategy of GPT-5. But there is something important in the research there is what we call the Cote model, chain of thoughts, improving intelligence modeling, reasoning, how we can simulate it. An idea is a semantic set of semantics chunks, semantic blocks, and how we can connect agents tomorrow with our own resources. Own could be personal, could be company, etc. That means advanced agentic AI is a step forward general intelligence, where we're going all through. And I didn't comment, but that's an image generated by Copilot of a professor talking to students about agentic AI in the future. And just the final slide will be a Gascon proverb for digital agriculture future and agentic AI. In an apple, you can count the seeds, but in a seed, you cannot count the apples. So many grains, many seeds there. And I hope you students will develop beautiful agents in the future in your private life, public life, or professional life. I'm quite sure of that. You are lucky to live in such a world. And that's a dedication. And the picture is myself as a child with my daughter, my father, and my grandfather, who was a farmer. He's a farmer in the southwest of France. And I dedicate that any conference on digital agriculture, I dedicate it to him. Thank you for your attention. And sorry for this problem this morning, but I'm through. I will send the PDF to my colleague, to Dr. Dibia, and hope you have questions. I cannot take question only one because I have to go to another meeting now. But if there is one question, I will be glad to answer it. And then, of course, you can become my friend on LinkedIn, and you can interact with me with private message on LinkedIn or email. And I will send the PDF to Dr. Dibia. So if you have one question, I can take it. Otherwise, we have to stop. Dr. Dibia, is there a question?
Yes, sir.
So the session is open for questions. Anybody can ask a single question. Dr. Dibya?
Yes, I'm asking them. So anyone has any doubt on this, you can just discuss with Sir. You can just ask your query to Sir.
Yeah, and we can continue. It's what I said to Dr. Dibia. For me, it's not only one shot, one conference. It could be the beginning of a partnership like I did in Africa. We're going to create an applied AI institute in Africa, funded by the French government. We could envision to have a joint project there exists some partnership, formal partnership in science between France and India. I was funded there 10 years ago with the University of Merida, with TCS, Tata Consulting Services. We had a beautiful project on NFC, NFC, and the use of NFC money, NFC cash. I forgot the name of the project, but it was a beautiful project. It was called the first project to provide a cash, virtual cash in the fields in India for
Yes, sir.
farmers. So we can have this kind of joint research project. Yeah, I'm totally open to keep on this partnership with India. And in digital agriculture, it's a world issue in France, in Africa, in India, in China, everywhere. So quite sure to do a lot of things. We already have two. We're going to have a third project funded by Europe on digital agriculture. So there is room for
Yes,
things there.
definitely, sir. Yes, sir. I will share the means your recorded session with all our other professors and our research scholars. So we will go through it. And today, of course, because of some parallel session, many scholars could not attend. But they were in the morning session. But this time they could not attend only because of the parallel session. But yes,
Okay.
they very interest on this part, sir. So I will discuss with my scholars, and I have personal interest on this topic, so we'll collaborate, sir. Surely we'll collaborate. We want to do some work under your guidance, sir.
With pleasure. Talk with you
And that,
soon with pleasure. And I send you the PDF. And
thank you very
bye,
much, sir.
everybody.
Thank you.
Thank you.
Yes, we are
Bye bye.
really privileged to have you in our session, and that's really a very interesting session, insightful session, sir. And thank you
Thank you very much.
once again, sir. I'll share
Bye
you
bye.
the
Thank you.
other things, sir. I will
Bye bye.
share the recorded part and the other certificates or everything from this very soon, sir. Once again, I thank you,
Thank
sir.
you. Thank you.
Thank you
Bye
very much.
bye.
Bye bye, sir. Bye bye.
Bye.